A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So, I was looking at the queue today, and Daniel's prompt is hitting on something that I think every developer has a love-hate relationship with, which is the where do I actually put my code problem. He wants to dig into workers, specifically things like Cloudflare workers, and how these ephemeral, blink and you miss them containers compare to the old-school persistent server.
It is a great rabbit hole, Corn. And honestly, it is the perfect topic for today because, full disclosure, our script is being powered by Google Gemini 3 Flash. So we are already living in the world of ephemeral, high-speed compute just by talking about it. I am Herman Poppleberry, by the way, for anyone joining us for the first time, and I had been knee-deep in V8 isolate documentation all morning because of this prompt.
I knew you'd have the manual out. You probably have a favorite isolate version, don't you? Don't answer that. Let's start with the basics for the people who still think a worker is just a guy in a high-vis vest. Daniel's asking about these server-side snippets that spin up, do a job, and vanish. In the world of 2026, where does the worker fit in between a standard cloud VM and something like a Lambda?
That is the crucial distinction. Most people hear serverless, and they think of AWS Lambda. And Lambda is great, it is the heavy lifter. But Cloudflare workers, and the worker model specifically, uses something called V8 isolates. Think of a traditional server or even a Docker container as a whole house. You have to boot the OS, set up the plumbing, start the runtime. That takes time, the famous cold start. An isolate is more like a single room within a massive, already running hotel. The hotel is the process, and the isolate is just a tiny, sandboxed environment for your JavaScript or Rust code.
So instead of building a house every time I want to make a sandwich, I'm just popping into a preheated kitchen.
Well, I promise not to say exactly, but you nailed the efficiency. We are talking sub-millisecond start times. While a Lambda might take a second or two to wake up if it hasn't been used in a while, a worker is live before the packet has even fully arrived from the user. It is essentially zero latency compute.
Okay, but if it's that fast and that cheap, because Daniel mentioned the paper request, zero cost when idle model, why aren't we running everything on workers? There's got to be a catch. I'm guessing it's not all sunshine and rainbows when you try to do something heavy, like video encoding or training a massive model.
That is the first big wall you hit. Workers are designed to be skinny. On Cloudflare, for instance, you usually have a memory limit of around 128 megabytes and a CPU execution time limit that is often measured in milliseconds, though they've pushed that to 30 seconds or more for certain unbound scripts recently. But if you try to run a massive library or do heavy image processing, the worker will just keel over. It is a scalpel, not a sledgehammer.
So it's for the logic layer. I'm thinking about things like checking if a user is logged in before they even hit my main server, or maybe redirecting someone from the UK to a different version of the site than someone in the US.
That is the classic edge use case. Because these workers run in hundreds of data centers globally, the code executes physically close to the user. If you have a persistent server in Virginia and a user in Tokyo clicks a link, that request has to go all the way across the Pacific. With a worker, the Tokyo data center intercepts it, runs your code, and gives an answer in 10 milliseconds.
But here is what I've been wondering, and this goes back to Daniel's question about persistent servers. If my database is sitting in a data center in Virginia, let's say I'm using a standard Postgres instance, does it actually matter if my worker is at the edge in Tokyo? Doesn't the worker then have to wait 100 milliseconds to talk to the database in Virginia anyway?
You have just identified the edge latency paradox, which is a huge topic in 2026. If your data isn't distributed, your compute being distributed can actually make things slower. The worker starts instantly, but then it sits there twiddling its thumbs waiting for the database half a world away. This is why we've seen this massive surge in edge databases, like Macromata or Cloudflare's own durable objects in D1. You have to move the data to the edge if you want the worker to actually feel fast.
It feels like we're reinventing the whole stack just to avoid a 1-second boot time. Is it really worth the complexity? I mean, I can go to a provider and get a VPS, a virtual private server, for $5 a month. It stays on 24/7. I can put whatever I want on it. I can store files on the disk. Why bother with this ephemeral? Now you see it, now you don't. Architecture?
Maintenance is the big one. If you have that $5 VPS, you are the sysadmin. You have to patch Linux. You have to worry about SSH security. You have to manage memory leaks. If your app gets featured on a major news site and 10,000 people hit it at once, that $5 VPS is going to melt into a puddle. A worker platform just shrugs and scales. It can handle one request or a million requests without you changing a single line of config. It is infinite scale for the lazy or the efficient, depending on how you look at it.
I prefer efficiently lazy. It's a badge of honor. But let's look at the other side of Daniel's prompt. He brought up GitHub Actions as an alternative. Now, when I think of GitHub Actions, I think of, I push code, now run my tests and tell me if I broke everything. I don't think of it as a worker in the sense of an API. Can you actually use Actions as a serverless backend?
You can, but it's like using a tractor to go get groceries. It works, but it's not what it was built for. GitHub Actions are essentially ephemeral virtual machines. When you trigger one, GitHub spins up a runner. Usually, a pretty beefy Ubuntu environment executes your script and shuts it down. The cold start for a GitHub action is usually between 15 and 40 seconds, so you would never use it for an API call where a user is waiting.
Right, hold on, person. Trying to buy this shirt. Please wait 40 seconds while I spin up a Linux kernel to process your credit card. That's a great way to have a 0% conversion rate.
But where Daniel's point gets interesting is the automation side. If you have a task that needs to run once an hour, say scraping a website or generating a PDF report, GitHub Actions is actually a very viable competitor to serverless workers because it gives you a full environment. You can install Chrome, you can run Python with heavy libraries, you can access your full code repository easily.
And it's free, or at least has a very generous free tier for public repos. I've seen people use it for flat data projects. You know, a script that runs every morning, grabs some JSON from an API, and commits it back to the repo.
That is a perfect use case. In that scenario, the cold start doesn't matter because no human is waiting. But if you try to do that with a Cloudflare worker, you might run into those memory limits we talked about. If your scraping script needs to load a headless browser like Playwright, a worker is going to struggle unless you use a specialized service. An action, however, handles that with ease because it's a real computer, just a temporary one.
So we have workers for high-speed, user-facing stuff. We have GitHub Actions for heavy, background automation. But then there's the cron aspect Daniel mentioned. Scheduled tasks. I feel like this is where a lot of people get stuck. If I want to send a Happy Monday email to my subscribers, do I put that in a worker cron or a GitHub Action cron?
It depends on the weight of the email. If you're just hitting a Mailgun API with a list of names, a worker cron is perfect. Cloudflare has a system called cron triggers. You write your worker, you give it a schedule, say 0900 every Monday, and the edge network just wakes up your code at that time. It's incredibly reliable and costs almost nothing.
But what if I need to generate a custom image for each of those emails? Something that requires a bunch of processing power?
Then you're back to the heavy side. You'd probably want a GitHub action or even a specialized service like Versal Functions. Vercel is interesting because they're kind of the middle ground. They use AWS Lambda under the hood for their serverless functions, which gives you that longer execution time up to 15 minutes on some plans, and more memory. But they also have edge functions, which are the V8 isolates we talked about.
It's getting crowded in the ephemeral compute space. You've got AWS, Cloudflare, Versal, Netlify, Supabase. Everyone wants to be the place where your code vanishes. For someone like Daniel, who's deep into automation and AI, I imagine the worker model is getting really interesting for AI agents.
It's huge for agents. Think about an AI agent that needs to intercept an incoming email, summarize it, and post it to Slack. You don't want a full server running 24/7 for that. You want a worker that sits in the flow. When the webhook from the email provider hits, the worker wakes up, calls the Gemini API, maybe the very model writing the script, gets the summary, and shoots it to Slack. Total execution time, maybe 2 seconds. Total cost, 0.001 cents.
It's the Legofication of the internet. We're moving away from these big monolithic blocks of code and into these tiny reactive pieces. But I have to ask about the developer experience. Because one thing I hate about cloud stuff is it works on my machine but fails in the cloud problem. If I'm writing code for a V8 isolate, I'm not really writing standard Node.js, am I?
You're not. And that is the biggest hurdle. You don't have access to the file system. You can't just tfs.read file synced. You don't have the full processd object. Many of the libraries you're used to in the Node ecosystem might rely on native C++ modules that just don't run in an isolate. Cloudflare and others have worked hard on Node compatibility layers, but it is still a bit of a minefield. You have to write worker-flavored JavaScript.
That sounds like a great way to spend a Friday night debugging why a string buffer library isn't working because of a missing global object. I think I'll stick to my sloth-paced development. But seriously, if you're a startup in 2026, is there any reason to start with a persistent server? Or do you just go worker first and only build a server when you're forced to?
The worker-first mentality is becoming the standard for APIs and front-ends. If you look at frameworks like Next.js or Remix, they are designed to be deployed to these environments. But, and this is a big but, if your application is a complex, stateful beast like a real-time multiplayer game or a high-frequency trading platform, the stateless nature of workers becomes a nightmare. Trying to sync state across thousands of tiny, ephemeral isolates is a computer science problem that most startups shouldn't try to solve on day one.
Right, because the worker doesn't remember anything. It's like that movie Memento. Every time it starts, it has no idea what happened 5 seconds ago. You have to hand it its tattoos in the form of a database connection or a KV store.
And that round trip to the memory takes time. On a persistent server, you can keep things in RAM. You can have a local cache that is lightning fast. You lose that with workers. So there is a trade-off. You exchange easy scaling and low maintenance for complex state management.
I want to go back to the GitHub Actions thing for a second, because Daniel mentioned them as an alternative for automated tasks. One thing I've noticed is that people are starting to use Actions as a sort of poor man's backend for things that aren't even code-related. Like, every 4 hours, check if this price dropped on Amazon and send me a Telegram message.
It's a very powerful pattern, and because GitHub Actions has such a massive library of actions, pre-written snippets you can just plug in, it's often easier for a non-coder or prosumer to set up than a Cloudflare worker. To write a worker, you need to know JavaScript. You need to use the Trangler CLI tool. You need to understand HTTP headers. To use an action, you can often just copy-paste a YAML file and you're done.
It's the no-code version of serverless, but I wonder about the ethics of it. GitHub is providing these runners for CI/CD. If people start using them as a general-purpose cron engine for their personal shopping bots, does GitHub start cracking down?
They already do to some extent. If you look at their terms of service, they are pretty clear that you shouldn't use actions for things like crypto mining or excessive non-development tasks. But a price check bot? That's a gray area. Usually, the bottleneck is the execution limit. You get about 2,000 minutes a month on the free plan. If you're running a heavy Ubuntu VM for 5 minutes every hour, you're going to burn through that pretty fast. A worker, on the other hand, gives you 10 million requests a month for $5. It's a different scale of economy.
So if you're doing it once a day, use an action. If you're doing it every minute, use a worker.
That is a solid rule of thumb. And also, consider the environment. If you need a specific version of Python or you need to run some weird binary that only works on Linux, GitHub Actions is your friend. If you could do it in pure modern JavaScript or Rust, the worker is almost always the cleaner architectural choice.
What about the Versal functions of the world? Daniel mentioned them in the same breath. My understanding is that Versal is basically just a very pretty wrapper around AWS Lambda. Is that still true in 2026? Or have they built their own worker engine?
They've done both. They have serverless functions, which are indeed AWS Lambda, great for standard backend logic, and they have edge functions, which are their own V8 isolate implementation. The magic of Vercel isn't the compute itself, it's the glue. They make it so you don't have to think about the infrastructure. You just put a file in an API-DT folder and it becomes a worker. It's that developer experience that people are paying for.
It's funny how much we pay to not have to think. We're essentially paying a premium for the illusion that servers don't exist. But they do. Somewhere, in a massive air-conditioned warehouse, a chip is still getting hot because I wanted to check a price on Amazon.
And that is the serverless lie, right? It's just someone else's server. But the abstraction is so powerful because it lets a single developer do the work that used to require a whole DevOps team. Daniel, with his background in tech comms and automation, probably sees this as the ultimate multiplier. He can build these complex global systems from his desk without ever having to call a data center or configure a load balancer.
It is a multiplier, but it's also a complexity trap. I've seen people build these serverless architectures that have 50 different workers, 3 different databases, and 4 different cron triggers. And when something goes wrong, they have no idea where the failure is, because the trace goes through 5 different ephemeral environments.
Debugging is definitely the final boss of serverless. On a persistent server, you can log in, check the logs, see what's running. In a worker, by the time you realize there's an error, the server that caused it is already dead. It doesn't exist anymore. You are entirely dependent on high-quality observability tools, Logflare, Axiom, things like that. If you don't have good logging, you are flying blind.
Flying blind in a preheated kitchen. I think we've found the title of your next technical paper, Herman. But let's get practical for a second. If someone is listening to this and they have a small project, maybe a personal blog or a little tool for their office, what is the starter pack for workers?
I would say start with Cloudflare workers because their free tier is almost impossible to beat. Grab the Wrangler CLI and just try to make a hello world that returns the user's IP address or their current city. It's a 3-line script. Once you see that response come back in 10 milliseconds from a data center down the street, the aha moment hits you.
And then what? How do they avoid the state problem?
Use a serverless-ready database. Don't try to connect a worker to a traditional Postgres database that expects long-lived connections. Workers will kill a traditional database because they open and close connections so fast that the database spends all its time doing handshakes. Use something like Terso, which uses libSQL and is designed for the edge, or Neon, which has a serverless driver.
It's a whole new ecosystem. You can't just bring your old tools to the worker party. You need the serverless version of everything. It's like moving to a tiny house. You have to buy the tiny furniture and the tiny appliances.
But the upside is that your tiny house can be replicated 10,000 times across the globe in a second. It's a very weird, very modern way to build. And I think Daniel's prompt really highlights the shift. We are moving away from the server as a destination and toward compute as a utility, like water or electricity. You turn the tap, the code runs, you turn it off, it's gone.
I like that. Although, as a sloth, the idea of things moving that fast makes me a little dizzy. I prefer my code to sit and ferment for a while. Maybe have a nap.
Well, even you would appreciate the zero maintenance part, corn. Imagine never having to update an OS ever again.
Now you're speaking my language. No updates, no patches, just vibes and JavaScript. So, to wrap this up for Daniel workers are these tiny, lightning-fast isolates for the edge. Great for APIs, middleware, and high-speed logic. Not great for heavy lifting or complex state. Use GitHub Actions for your heavy, background tasks, and long-running crons. And if you're using Vercel, you're probably using both without even realizing it.
That is a perfect summary. And honestly, the competition between Cloudflare, AWS, and Google in this space is only going to make these tools better. We're seeing WebAssembly or WASM becoming a big part of this too, allowing you to run C++ or Rust at near-native speeds in these tiny isolates. The skinny worker is getting a lot of muscle.
It's a fit worker now. It's been hitting the gym. Well, this has been a deep dive. I feel like I need to go lie down in a persistent environment for a while.
Before you do, we should probably thank the people who make this ephemeral show possible. Big thanks to our producer Hilbert Flumingtop for keeping the gears turning behind the scenes.
And a huge thanks to Modal for providing the GPU credits that power our AI collaboration. They're actually a great example of this, giving developers access to massive compute without the infrastructure headache.
This has been My Weird Prompts. If you enjoyed our 2026 flavored dive into the world of workers, we'd love it if you could leave us a review on Apple Podcasts or Spotify. It's the best way to help other curious humans and AIs find the show.
You can find all our past episodes and the RSS feed at myweirdprompts.com. Thanks for listening, and thanks to Daniel for the prompt that made Herman read way too many technical manuals this morning.
Worth it. See you next time.
Catch you later. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth from man, from long-eared host. My Weird Prompts, until next time, stay curious, keep weirding.